what I'm going to do is say, well, I can't really calculate this. So what I'll calculate is something close. What I'll do is I'll take this thing here, and this thing here is something like y of t of n plus 1 minus y of t of n over t of n plus 1 minus t of n. So I've discretized my space and time. At time t of n plus 1 is my future time. So now I'm thinking about my delta t being the difference between t of n plus 1 minus delta t, n. And so I'll call this object here y of n plus 1. Okay? So I'm going to use this here, and I'm going to say now what I'm going to do is replace this formula here by y of n plus 1 minus y of n over delta t equals f t y. I still have a divide by delta t, but now delta t is not 0 because I've said, oh, in fact, sorry, not quite right. This isn't an equals anymore, right? Because I'm not taking delta t to go to 0. I'm taking delta t to just be small. Now, this is an approximate relationship. Okay? Now, notice what I can do with this. I can multiply by delta t. I can move that to the other side, and what I end up with is y of n plus 1 is equal to y of n plus delta t times f t of n y of n. And we'll evaluate this function at the current time. And notice what this tells us. This is called the Euler formula. Do you like how I box that? So for those, I'm doing that just for the sake of the engineers in the class because they know now it's so important. Because I put a box around it. Okay, and that's what you turn in. There. Okay. This is called the Euler formula. It is the simplest solution in some sense numerically to a differential equation. Because what it allows you to do is to say, hey, look, how does this work? How do I predict the future? Well, it's not so bad. My solution, delta t into the future, is what it is right now plus a little bit of something. A little bit. What do you mean a little bit? Delta t is small, isn't it? I said it has to be small if I want to kind of make this approximation work. So my future is my current plus a little bit, and this is telling me how I should add to my current solution to predict the state of the system in the future. Okay? Now, presumably, if I take delta t to be small, this should be fairly accurate. So before the advent of computers, right, what you had was a way to think about, okay, I can actually numerically calculate some of these things by just plugging it into a formula like this. Okay? And the idea is I'll just iterate. Iteration is great. You know what your computer loves to do at night when you're sleeping and it's just not being slave to your hands pounding on the keyboard? It likes to iterate in its sleep. Okay? Loves doing stuff like this. You can tell it iterate all day long. It just goes, it'll even heat up and blow up if you're not careful.